In this video, we're going to talk about the oxidation of thiols and sulfides. Now, thiols are an alkyl group with an SH coming off of it as a substituent. Those are called thiols, if you remember. And when they undergo oxidation, the carbon does not get oxidized, but instead the sulfur gets oxidized. The sulfur atom itself gets oxidized. So here I have this is butyl thiol, or butane thiol, it's called. And I can oxidize butane thiol with nitric acid. There are other types of oxidizing agents that I could use. Nitric acid works pretty well. And when I oxidize a thiol with nitric acid, notice I'm oxidizing the sulfur atom, not the carbon. I'm oxidizing the sulfur. So this is very different than oxidizing alcohols. When I oxidize alcohols, the carbon gets oxidized that contains the OH group. Here, the sulfur gets oxidized, and I generate sulfonic acids. Right. So this is a sulfonic acid. Now they can also form disulfide bridges if we use milder oxidizing agents, and those milder oxidizing agents are bromine or iodine, right? So bromine and iodine are fairly good oxidizing agents, but they're mild oxidizing agents. And what happens is if I take a thiol and treat it with bromine or iodine in the presence of sodium bicarbonate and dichloromethane, I form a disulfide bridge. So notice I essentially have two thiols that form a sulfur-sulfur bridge. And it's called a bridge. These are very prevalent in our hair, right? So our hair structure has disulfide bridges. When people go and get perms in their hair, what they're doing is they're actually breaking those disulfide bridges and then chemically breaking them and then retreating them so that they form in particular patterns, and that's how you get the kind of the structure of your hair to get to get it to go from straight to curly, or vice versa. So this is a disulfide compound. Now sulfides, not thiols, but sulfides, have a formula that's RSR. So instead of RSH, we have RSR, two R groups coming off of a sulfur atom. And they're often called thioethers because an ether is ROR and a thioether is RSR. So sulfides and thioethers are the same thing. Kind of keep things straight in your mind. And they're oxidized fairly readily with hydrogen peroxide. So if I take a sulfide and I treat it with hydrogen peroxide, I get this, and this is called a sulfoxide, right? So dimethyl sulfoxide is formed from dimethyl sulfide reacting with hydrogen peroxide. Now, if I treat sulfoxides with another equivalent of hydrogen peroxide, I can oxidize the sulfur even further, and I get sulfones. Sulfones, right? So with one equivalent of hydrogen peroxide, I get sulfoxides, and with two equivalents of hydrogen peroxide, I can get sulfones. So here I have my thioether. I treat it with one equivalent of hydrogen peroxide, and I can generate a sulfoxide. Right? So notice sulfur oxygen double bond. Now there is a way where I can directly oxidize a sulfide to a sulfone, and that's by using peroxy acids. So here is an example of my sulfide reacting with peracetic acid. And if I treat that with peracetic acid, now the sulfide becomes a sulfone, where I have two sulfur oxygen double bonds present, right? A sulfone. Okay?